All right, Algebra 2, we are getting ready for the last universal screener of the year. We decided it would be smart to do a little bit of a chat here with some similar type problems just to get you thinking about this again. If you are watching this video, I appreciate the fact that you are taking the time to watch this to try and make things go better, not only for you, but to make things look better for us too. So I am going to zoom back out just a little bit here so we can see all of the different words. This key itself will be online when we get done with this, so you can see it there too. But hopefully you listen a little bit here to get you some extra help. Okay, number one, which of the following represents a circle in the coordinate plane that is centered at -2, 6 and has a radius of 7 units? Okay, all we're basically doing here is we are going to be taking this form sorry about that, and filling in values. Now the simple way to look at that is when I go to plug these in for my x and my y, you want to work with the opposite. So in other words, when I see the -2, that means I'm doing x plus 2 because I'm subtracting -2. That's why the opposite occurs. And with the y, I'd have y minus 6 squared. And then I square my radius. Squaring 7 gives me 49. And then I want to be careful, make sure I pick the right one, because there's a lot of ones that are similar over here. Okay? But again, just take the opposites of your x and y when you're plugging them into the form, and then remember you're still squaring your radius. Okay? Just looking for some things with our basic circle. Talked about that a little earlier in the year, but it's been a while. Okay, which of the following is a solution set to this? Now some of you may look at this and go, well, that's no big deal. I just need two numbers that multiply to 20 and add up to 4. Okay, oh boy, crap. Because here, if I use two positives or two negatives, they're not adding up to 4. I can try every possible number combo I can think of, it's not going to work. Well, what do I do then? Well, we got to go back to the quadratic formula. The what? This guy. Oh yeah, okay. So when we get stuck heading this direction, again, my A, B, and C values are just the values that I have for coefficients in each of my terms. So -4 plus or minus B squared minus 4AC all over 2A. If I can just remember this well enough, then, let's see, 4, 1, and 20 would be 80. Ooh, another interesting thing I'm noticing coming up here. What happens if I have a negative underneath my radical? Yeah, we gotta pull an eye out. Where's my eyeball when I need it? Oh well. So here, when I pull the I out, what's the square root of 64 that's left going to be? Okay, that's going to be 8. So this is 8I. Because the I whips our negative out of there, and then the square root of 64 is 8. So I get here, and I'm like, ooh, I'm going to start canceling. Oh, wait, I got to think about this. There's a bond. But all three of these are divisible by 2. So I can take a 2 out of each of those and end up with -2 plus or minus 4i. Most of the time, if you get something like this that's not factorable, the possibility of it being one of these answers is not real good. So those I'd kind of avoid and just stick to the ones that have I. Work with those a bit. Nothing too bad. Okay, 3. Which of the following is not a factor of x to the 4th minus 16? Now hopefully you look at that and you recognize, ooh, I can square x squared to get x to the 4th. I can square 4 to get 16. So I'd have x squared plus 4, x squared minus 4, because it's a difference of squares. But then you take one more look, because you're like, ooh, not a factor, it's neither of those two. I can break this down still. So let's do that. what do I square to get 4? 2. X plus 2, x minus 2, and I have my one left that's not a factor. A lot of times on these tests, the ones that are similar are going to be the ones that aren't the answer, and the oddball will be the answer. But just to be sure, we need to know what we're doing. Which of the following represents the polynomial shown below? Now, do I really want to type all these into my graphing calculator until I find one that looks like this? No, not really. So here's what I would suggest. I notice a couple of things. I notice a 0 here, where it touches the x-axis, and I notice another one here. Okay? So it looks like my zeros are at 0 and 4. So which one of the problems is going to give me that? Well, I start to look and I'm like, okay, well, I think this is where I'm going to be able to double check using the calculator. I start to look and I'm like, well, there's only 2 answers. So any place where I see there'd be 3 answers, it's probably not going to be that one. So let's see. If I plugged in 0 there, yeah, that'd wipe it out. 4, maybe it's this very first one. That'd be nice. So I start to take a peek here. Nope, not that one. It's like, dang. Well, what's happened here is, we talked about this, but very briefly before. When you have a curve that comes up, hits the axis, and comes back down, this is often referred to as a double zero. Okay? And what happens with a double zero means you're going to end up with 2 values that are 0. So it'd be like having 0, 0, and 4. Well, if I have that, if I have 3 answers, my degree needs to be 3. Well, here, x and x would give me a degree of 2, so that wouldn't work. X times x is x squared again. This would need to be a degree of 3. That's only 2. X squared, nope. So it's got to be one of these 2 guys. And then I look and I'm like, well, wait a minute. If it was D, -4 would be an answer, because I'd be able to set this equal to 0 and get -4. So it's not D, it should be E. Now let's take a look here, just to make sure. You're like, dang, Hardy, with this explanation, we could have typed all 5 of them in. I suppose, but with time being an issue, you really don't want to have to type all 5 of these in. Yep, there it is. Okay, so it's definitely E. But again, I could type them into the calculator too, especially if you're a fast typer, but just wanted you to be aware of those to make sure that was going all right. Now, everybody should be getting number 5 right. Okay, from the top of a 40-foot firehouse, a cat is located walking on the street 100 feet from the base of the firehouse as shown below. The angle of depression can be found using which of the following equations? Now remember, angle of depression. If I look at it this way, that angle's actually here in what I have. So, what sides am I working with my 40 and my 100? Opposite and adjacent, which means we're looking for the tangent. And the one thing I noticed here as this was written, where are all the little -1s? Well, they need to be there because I'm looking for an angle. So shame on me for not having that there. But it ended up being that middle one. This is a really messed up problem. I could look at all those A choices. Wish it were a bubble sheet. I have a 4 out of 5 chance. But that's, again, something I have to watch to find my angle and then use my trig function. For 6, Mr. H has a bag of candy that contains 10 Jolly Ranchers, 8 Starburst, and 7 Hershey Kisses. What's the probability that Mr. H reaches in, grabs a Starburst, 8 out of 25, eats it, so it's gone, then reaches in and grabs a Jolly Rancher? Well, I ate the Starburst, so there's only 24 left. And grabs a Jolly Rancher, 10 out of 24. Whenever we're doing anything with probability, okay, you're always just multiplying the options together. And then I just keep reducing my fraction until I can't anymore. And I'm good. Okay. So anytime there's probability, we're just going to multiply across. and then simplify the fraction. But watch for things like eats it or puts it back in the bag, because those types of things can change things up. E7. Which of the following is equivalent in our exponent rules? Make sure it goes to the 4 as well as everything else. So 4 to the 3rd, x to the negative 9th, y to the 18th, over x to the negative 6th. Now what do we do with negative exponents again? We flip them. 4 to the 3rd, not a negative exponent, it doesn't flip. X to the 9th, down you go. Y to the 18th, you're good. X to the negative 6th, you need to flip up. I'm still not quite done. Still have these x's to deal with. So what's the rule when you're dividing with exponents? Okay, we're going to subtract the exponents, 9 minus 6, and my solution goes where the bigger exponent is. X to the 3rd, and we're good. Logarithms, just went back over these, so this should be a piece of cake. Get your log alone before you do anything fancy. And then how do I get rid of the log of base 4? That's right, exponentiate. And in looking at all these, the only one that looks anywhere near big enough to be 4 to the 10th is the big old number in the middle. So that's our answer for this one. Which of the following is equivalent to this? Okay, I need to multiply this out. Whether some of you decide you are going to go the parenthesis route and just go with all these arrows, that is not my preferred way of doing things, but you do as you wish. Especially when it gets this large, I am a big fan of this. Now, some of you are saying, wait a minute, that looks familiar, that pattern. And it does, and you're going to see it in just a minute, and then I'm going to go, oh, why didn't we think of that to begin with? Multiply to fill in your box. And then start in the upper left-hand corner and start combining like terms. Oh, they cancel out. Oh, they cancel out. Oh, it was a difference of cubes. Cube x to get x cubed, cube 2 to get 8, the minus is in the middle, off we go. Now again, notice I can still get to the right answer, but wouldn't it be cool to just be able to look at that and go, wait a minute, perfect cube, oop, it's minus in the middle, yep, that's it, be awesome. But again, we have options. Oh, we're almost there. It's good review, this is a good review for the ACT even. Which of the following represents a line that is perpendicular to this line and goes through the point? Okay, perpendicular. Negative reciprocal. In other words, my new slope is going to be the flip of this and switch the sign, which is negative 3/2. So to get my equation, I could use point slope form, or I could use regular old y equals mx plus b and just plug my values in. Y equals mx plus b. Negative 12 over 2, add 6. Okay, there's a 9, but my slope is negative 3/2. For shame, Hardy. For shame. Man, somebody needs to smack the guy who has been making these worksheets. Oh wait, that's me. Never mind. Go a little easy on him. It's all right. Okay, I know, that was kind of dorky. Oh, number 11. We had to have a little comic relief in the middle here. So which of the following represents the solution to the system? I need to be able to cancel out x or y. So let's see here. If I want to cancel out the x's, I can multiply this one by negative 3 and this one by 2, because I want these to be opposites. Because if I just did 3 and 2, it would be 6x and 6x, and I wouldn't cancel. So by doing a negative up top, or I could have done it down below, now when I add down, x's cancel, divide by -5. Now this is where you become an ACT taking master. Look at your answers. How many answers have a y value of 10? One of them, C. Circle it and go on. You don't have to know x and y. Nobody's ever going to know. Not even me. All right, if f of x is 3x minus 4 and g of x is x squared plus 4, which of the following represents f of g of x? So you're like, oh crap, here's this again. F of g of x. In other words, plug in what's in the parentheses any place you see x. So 3 x squared plus 4 minus 4. Distribute. Simplify the like terms. Woohoo! And again, just kind of go through this. We'll have a few chance for a little questions here before we get to the universal screener. But going through this and kind of seeing some things will have you have a really good chance to do even better this time than the last.